Okay, guys, so we're moving on to a new unit today, and it's called linear versus exponential. So we're going to talk about linear functions and exponential functions and how to basically tell the difference between the two. And then a little bit next week, I think it is, next week-ish, we're going to talk about writing the equations, how to write the equations of both linear and exponential functions. Okay, so this for today and tomorrow, we're just going to talk about how basically to tell the difference, how to tell if it's a linear or how to tell if it's exponential function. So I have like this little guide that's going to help us tell the difference between the two, and that's what we're going to talk about today. So let's go ahead and start talking about, and if it's an equation form, how do I tell the difference if it's an equation form? Well, a linear equation is in the form, okay. Let's try this again. Y equals mx plus b. Okay, so you guys all seen that before, although my B looks like a D right now. There we go, B. Okay, where, let's say, where M is my, it's my slope, right? But since we're not talking about that right now, we're talking about, once we start writing the equations, I want to use words that, kind of go along with that and what we're going to talk about next unit also. So I'm going to kind of tie all these words together for you. So this is slope. I'm going to tell you, you guys know that slope. It is slope, but that's not what we're going to call it this time. We're going to call it our God, I'm so sorry. I can't even think today. In a linear equation, this is going to be our common, I'm going to spell common wrong just so you know. Common common difference. So it's going to be our common difference. Whatever the difference is between, in our table, whatever the difference is, or in our story problem, whatever's changing, whatever that value is. So we're going to talk about that more in a little bit. And then B, we know is our y-intercept. But in this time what we're going to call it is our zero. There's a couple other things we can call it, and we're going to call it our zeroth term. And that's the one I like, is zeroth term, because because in all the different representations we can make, we can always find a zeroth term, which is why I kind of like the word zeroth term. But Miss Gilpin likes the word initial value, and it's about the same thing. It means exactly the same thing. It's just different words, initial value. And when you go to physics, by the way, if some of you guys are in physics now or will be in physics next year, initial value is the word is the definition. Oh, yeah, that person's not getting in. That person's not getting in. Initial value is the vocabulary that they're going to use. So for science terms, they're going to use initial value, and the initial value is when x equals 0. Okay, so that's what we're going to talk about. Is those are the vocabulary terms we're going to use for the next couple weeks, probably until Christmas. So zeroth term is the one I'm going to use, initial value. And my common difference, I, however, am not going to spell out common difference every time we talk about it. So what I call, sorry, I keep forgetting that I'm in highlighter mode. What I'm going to call it is just my CD, common difference. I just abbreviate that, okay? So I want you guys all to know that. So that's what a linear equation looks like, mx plus b. So what does an exponential equation look like? Well, it looks like this. Y equals a times b to the x power. Okay? So it looks a little different, a times b to the x power. And we're going to talk about the words here also. So a happens to be my 0th term again. 0th term. Or my initial value. When x equals 0. Okay, that's what we're talking about, my initial value. Not when x equals 1, when x equals 0. Your little friends are back, Ketland. Saying that you keep giving them the code.
I'm not giving no code.
I know, honey, but that's just what they're saying. And then b in this term, I know that there's a b in both equations, and that sometimes gets a little confusing. So you got to kind of remember if it's linear or if it's exponential. Sorry, I have to check someone else into the class. B in this case is my common ratio. Okay, so, and I'm going to abbreviate that CR, so I'm not having to write out common ratio the whole time, all the time. Okay. Okay, so that's how I tell the difference of the equations. So I'm going to look at the equations and tell if they're linear or exponential. And the big difference, I'm going to just point this out here, is where my x is. If it's an exponential equation, guess what? My variable is the exponent. Exponential, the variable is the exponent. Okay? If it's linear, it's just an x by itself. There's no x squared. It's not an exponent. It's not in the denominator. It's just mx plus b. Okay? So that's how I tell if I'm just looking at an equation. If I only see an equation, and we're going to practice this in just a little bit. So we're going to go to Nearpod. We have some practice problems to work out. Okay? So this is kind of a guide for you guys to look at. Oh, so somebody's friends just called me a little, I am just not happy with your little friends, you guys. Whoever's doing this and giving your friends the code to my room. So if we're looking at a table, for linear, this is what we look at. So it's a common difference. When I'm looking at the differences, either a common difference or a common ratio, when I look at this, it's going to be finding my differences in my y column, as long as my x columns have a difference of 1. If it has a difference of other than 1, I have to do something else to it, and we're going to show you that in just a minute, okay? So on these examples, as you can see, my difference... Why do I always do that? My difference here is 1, right? It goes 0, 1, 2, 3, 0, 1, 2, 3. So they're counting by ones on that column. So we're going to find the difference in my y columns, and that's going to be my common. If it's a linear equation, that's my common difference because I'm adding the same number, and then if it's exponential, I'm multiplying the same number every time, and that's the main difference between them. So I'm multiplying. How do I get from 1 to 3 and 3 to 5 and 5 to 7? What am I doing in that table to get from there? Can someone tell me? What do I do to get from 1 to 3 and 3 to 5 and 5 to 7? What am I doing every single time? Anybody?
And this has happened a few times, man. No cap.
Yeah. Okay, so how do I get from 1 to 3? Well, I'm going to add 2, right? And how do I get from 3 to 5? I add 2. And how do I get 5 to 7? So if I'm looking at my tables and I look at my tables, right? And I look at my y values and I see what's happening, how I get from one number to the next number to the next number. Oh, that does not look like a 2. A 2. And I'm adding the same number every time, then that means it's a linear function. Okay? So if it's an exponential function, what do I do here? Well, if I'm looking, how do I get from 1 to 2? Well, that would be add 1, right? 2 to 4, add 2, add 4. Well, that's not adding the same number, so that's not it. How else can I get from 1 to 2 and 2 to 4 and 4 to 8? Well, I can do times, right? So 1 times what number equals 2? Times 2. And 2 times 2 is 4. And 2 times 4 is 8. So if it's exponential, I'm multiplying by the same number every time. Does that make sense? Oh, I should put a little star there. Okay? Are you guys okay with that? So I'm multiplying by the same number every time. Okay, so now we're going to look at the graphs and what it looks like if it's a graph, if it's the same, if it's linear or exponential. And all I'm going to do is I'm going to use the table and I'm going to plot the points, okay? So we're going to just see what it looks like graphically. By the way, when you guys are doing this, I'm just going to give you a picture of a graph. I'm just going to give you a picture of a graph, and then you're going to have to tell me if it's linear or exponential. So you need to know what they look like, and how we're going to do that is we're just going to graph these tables so you can see kind of what a linear exponential graph looks like. So if I have 0, 1, and then 1, 3, and 2, 5, and 3, oh, it fits, 3, 7. So this is what a linear graph, I probably missed a few spots. It looks like, right? If it's linear, it's going to be a line. It's right in the name. Linear means line. It's a straight line, okay? So if I see a picture, which I'm going to show you guys, that's going to be part of your homework. You're going to see a picture and they're going to say, what is this, linear or exponential? If it's a straight line, it's linear, okay? So it kind of helps the word linear line kind of go together. So now let's look at the other graph. So we still got a point at 0, 1. 0, 1. And then we got 1, 2, and 2, 4, and 3. Oh, 8 is not on my graph. We'll just go right there. 8. Okay, and then if I go backwards, I want to see if I can go backwards. So if I go back here, if I'm multiplying by 2 here, if I'm going backwards, I'm dividing by 2. If I'm undoing it, so if I'm going this way, I would be dividing by 2. So 1 divided by 2 would be 1/2. So -1 would be 1/2. And notice it's just getting smaller and smaller. It's by 2 every time. It's cutting in half every time. Oops. Sorry, my graph skills are not so, my drawing of lines are not so good. So this is what an exponential looks like. It's kind of a curve, right? Has a straight line. It kind of looks like it's flat. It's going to go towards 0. It's not really. And then it curves up. So this is what an exponential graph looks like. So let me try and make this smaller here. So this, if you can take a picture of this, if you don't have it, you know, I'm going to save it toward on our notes, so you guys will have it there all filled out. But I think you might need this when we go to our next little activity here. So if you'll take a picture of this so you have it with you, so you know what linear is and what exponential is, and then we are going to go